So Pythagorean theorem is talking about a special case with a right angle triangle. Okay, so the Pythagorean theorem is a special case about right angle triangle. And a triangle that has a right angle on it is called a right angle. So this is called a right triangle, which we can find an angle inside it. It's 90 degrees. Okay, then for any triangle, we can find the angles, but once we will find a right angle, so we can say that this one is called a right angle triangle. We have the longest side opposite to the right angle. This side is called hypotenuse. So in this case, we have two sides and we have the hypotenuse. So the greatest one here is called the hypotenuse. Okay, then what the meaning of hypotenuse? Adam and Jenna, what the meaning of hypotenuse? Adam and Jenna, you can hear me?
اللي هو الأكبر حتة في الترينجل.
Adam?
He was this really smart dude who lived a long time ago in ancient Greece, and he proved the theorem. Well, historians aren't completely sure it was actually Pythagoras who proved it. It could have been one of his students or followers, but he usually gets credit for it. Anyway, the main thing that you need to know is that the Pythagorean theorem describes an important geometric relationship between the three sides of a right triangle.
So the Pythagorean theorem is related to a special case which it could be worked with only what? Right triangle. It could be worked with only right triangle. So we couldn't work with acute or obtuse
We're going to learn what that
triangle.
relationship is in just a minute. But first, there's several things that you'll need to know before you can truly understand the Pythagorean theorem or use it to solve problems. First of all, to understand the Pythagorean theorem, you need to know about angles and triangles. And you also need to know a little bit about exponents and square roots. So if those topics are new to you, be sure to watch our videos about them first. And second, even though the Pythagorean theorem is about geometry, you'll need to know some basic algebra to actually use it. Specifically, you'll need to know about variables and how to solve basic algebraic equations that involve exponents. We cover a lot of those topics in the first 5 videos of our Algebra Basics series. Okay, now that you've got all that background info covered, let's see what the Pythagorean theorem actually says. The theorem can be stated in several different ways, but the one we like best goes like this. For a right triangle with legs A and B and hypotenuse C, a squared plus b squared equals c squared.
So this is the theorem which we want to talk about today. The Pythagorean theorem for a right triangle with legs A and B and the hypotenuse is C. So if I want to draw a triangle, right angle triangle, so we can say that the two legs, those two sides are called two. This is the hypotenuse. Then this one, we can say that this is called leg. And the second one, this is called leg. And the third is hypotenuse. Okay, so the longest side in a right angle is called what? It's called hypotenuse, right? So we have to work only with a right angle triangle, and the two sides around the right angle is called legs, and the longest one is called the hypotenuse. After that, we can say that we want to write the names for each one. So I can say that this one is called A, and this one is B, and this one is C, right? So we have A, the two legs, one is A and the other is B, and this one is C. So the theorem is A squared plus B squared equal C squared. Okay, so let's take an example about this.
As you can see from this definition, the Pythagorean theorem doesn't apply to all triangles. It only applies to right triangles. As you know, right triangles always include one right angle that's usually marked with a square right angle symbol to help you identify it. And you need to know which angle is the right angle because it helps you identify an important side of the triangle called the hypotenuse. The hypotenuse is the longest side of a right triangle, and it's always the side that's opposite of the right angle. In other words, it's the side that doesn't touch or help form the right angle itself. In order to use the Pythagorean theorem, you need to be able to identify the hypotenuse because that's what the variable c stands for in the theorem. C is the length of the hypotenuse side. The other two sides of the triangle, the ones that do touch or form the right angle, are called its legs. Our Pythagorean theorem definition uses the variable names a and b to represent their lengths. Oh, and it doesn't matter which leg is called A and which leg is called B, as long as you keep track of which is which.
Okay, understood this point? Understood this point? This is A and this is B. Even if we will switch A and B, doesn't matter. It will give us the same answer. Okay?
After you make your initial choice. Okay, now that we know the various parts of the Pythagorean theorem, let's think about what the relationship or equation a squared plus b squared equals c squared is really telling us. It's telling us that if we take the lengths of the two legs, sides A and B, and square them, which means multiplying them by themselves, a squared is a times a, and b squared is b times b, and then if we add those two squared amounts together, they will equal the amount you'd get if you square the hypotenuse side, which would be c squared or c times c. That may sound a little confusing at first, so let's take a look at a special example of a right triangle that will help the Pythagorean theorem make a little more sense. This right triangle is called a 3, 4, 5 triangle because its sides have the relative lengths of 3, 4, and 5.
Do you see this triangle now? We have 3, 4, and 5. Could you please tell me where are the two legs in this question? Where are the two legs?
Four or three.
4 and 3, yes. And where is the hypotenuse?
5.
5, yes.
And by relative lengths, I mean that the units of length don't really matter. The sides could be expressed in any units, inches, meters, miles, whatever. So the triangle could be of any size as long as its lengths would have the proportions 3, 4, and 5 relative to each other. Starting with the side that's 3 units long, which we'll call side A, what do we get if we square that side? Well, in arithmetic, squaring 3 means multiplying 3 times 3, which equals 9. And the geometric equivalent of squaring something actually results in a square shape. As you can see, this square contains 9 unit squares. So this red area represents the value a squared in the Pythagorean theorem. Next, let's look at the side that's 4 units long, which we'll call side B. Squaring 4 means multiplying 4 times 4, which is 16. Again, the geometric equivalent of that is a literal square that is 4 units on each side and covers a total area of 16 units. So this blue area represents b squared in the Pythagorean theorem. And finally, let's deal with the hypotenuse, or side C, which is the longest side. It's 5 units long. Squaring 5 means multiplying 5 times 5, which is 25. And the geometric equivalent is a 5 by 5 square that has an area of 25 units. So this green area represents c squared in the Pythagorean theorem. Now that you can see how the arithmetic parts of the Pythagorean theorem are related to the geometric parts of this right triangle, let's check to see if the Pythagorean theorem is really true, at least in this special case. On the arithmetic side, if you add up the amounts a squared and b squared, they really do equal c squared because 9 plus 16 equals 25. And with a little rearranging of our unit squares, you can see that the area of the squares formed by the two legs really does equal the area of the square formed by the hypotenuse. Wow, those ancient Greek dudes really were smart. Okay, but I know what some of you are thinking. That's cool and all, but why should I even care about the Pythagorean theorem? What's it good for? Well,
it will be the area of the square on the hypotenuse. Now we have a question. In this question, we missed the hypotenuse or a side. In this question, we want to calculate what? Which one is missing?
Hypotenuse.
Hypotenuse. So how we are going to solve that question? Now we have this one represent what? This one represent A, right? And this one represents B. And we are looking for what? For C. Did you remember a rule which we can use it here? Should be what? Should be A square plus
plus B
B
square
square, yes, equal
equal C square.
C square. Thank you. So equal C square. So we have A square plus B square equals C square. Then we will put now, we have 3 to the power of 2 plus 2 to the power of 2. Adam, could you please tell me the answer, Adam? Equal
9 plus 4
square. Yes, so it will be 9 plus 4
equals 13.
equals 13. So we have C squared equal 13. So how we will find the value of C, Adam?
Squared plus B squared equals C squared.
No, we will find
Then,
C by using the square root for both two sides, okay? Because this is C squared and we are looking for only C. Then once we put C squared under the radical sign, so we will cancel square with the radical sign, which means C equal root 13. And we use addition because we are looking for the value of the hypotenuse. Okay, understood this part? So this is how we can find the value of the hypotenuse. We will use the formula A square plus B square equal C square. Minus, yes. Could you please tell me, we can write now here that this one is A, right? So I'm looking for A square. So once you are looking for A square, so it will be C square minus B square, right? Now we will calculate 6 square minus 4 square. It will be 36 minus 16. 36 minus 16, it will be equal 20. Then how we will find the value of A now? The value of A will be what? Square root 20. Okay, then A equal, if I want to answer this question without using calculator, we are going to search about a number, a perfect square number, which we have a root, then 4 times 5. Now we can find the root of 4, then the value of A, it will be equal to root 5. Okay, so we have A square, all of this represent A square. After that, we are looking for the value of A, then we will find the square root of A. Understood?